Hi, my name is Helen Sarah, and I'm a technical staff consultant at ChemTreat focusing on Legionella. As a member of both the ASHRAE and Cooling Technology Institute committees that have developed documents addressing Legionella, I will be discussing the topic Legionella and control practices to help minimize the bacteria in your systems. Many customers have questions about Legionella and how to control the bacteria. This presentation will help to answer some of these questions. I will start by reviewing some facts about the bacteria, introduce some key concepts, and then provide you with some resources for additional information. There are many different groups of bacteria. We're going to be speaking about the group Legionella, or the genus Legionella, and this chart will provide a hierarchy for Legionella. We'll start with the genus, and within this genus are many species. Legionella has upward of 50 species. We are particularly interested in the Pneumophila species, as this accounts for 90% of infection. Within the species are serogroups, and within Pneumophila are many serogroups. We are interested in Legionella pneumophila serogroup 1, as this sequence accounts for most cases of illness. When testing for Legionella, most laboratories will typically provide a result for Legionella pneumophila serogroup 1 if present. Legionella bacteria are present in environmental waters and have been found in soils. The bacteria grow in man-made aquatic environments and devices such as those listed on the screen. Complex plumbing systems create an often overlooked risk. An interesting fact is that potable water systems account for most of the cases of disease. All of the sources listed operate at temperatures favorable for the growth of Legionella. The bacteria grow best at 77 to 113 degrees Fahrenheit, or 25 to 42 degrees Celsius. We see the bacteria die off above 140 degrees Fahrenheit, or 60 degrees Celsius. Legionnaire's disease is one of two illnesses associated with exposure to water droplets or mist that contain the bacteria. There is less information about Pontiac fever, the other illness, which is a flu-like illness with no associated deaths. Legionnaire's disease is a respiratory infection presenting as pneumonia that can strike those who smoke, have compromised immune systems, or underlying illness or disease are more prone to getting sick. One cannot get sick from drinking water that contains the bacteria unless one aspirates the water such that it enters the lungs. And there is a 2 to 14-day incubation period from the time of exposure to illness. There are two key concepts I would like you to understand when addressing Legionella concerns. Legionella proliferate in biofilms. Biofilms form on moist surfaces when microorganisms secrete polymeric substances that are sticky or slimy. This is the biofilm. This biofilm can build up as it will attract any debris flowing through a water system, and the biofilm will grow in size. Legionella proliferate in higher life forms such as protozoa or amoeba that feed on the biofilm. And the goal here is to prevent biofilm growth within these source systems. The second key concept I would like you to understand, and that can help control biofilm growth, is flowing water. Keep water flowing, diminish dead legs in stagnant areas, and treat the water. In this depiction of a cooling system, you can ensure that water is flowing and that the water is treated. We want the water to reach all parts of any auxiliary equipment, such as a chiller, or any process equipment, such as a plate and frame heat exchanger. So we want to make sure that all associated equipment sees treatment, sees water. And account for equipment being offline or idle. Be sure to have a procedure for equipment rotation and a treatment program for bringing idle equipment back online. An effective water treatment program can keep systems operating efficiently and help control Legionella. Within a cooling system, when specifying water treatment, ChemTreat's goal is to control corrosion, deposition, and biofouling. The triangle concept, which many of you may be familiar with, depicts the relationship of these three control parameters. Each parameter on the triangle can affect each other. Biofouling can affect deposition and corrosion, and likewise, the other two parameters can affect biofouling. There are many organizations that have published documents about Legionella, and recently, the Cooling Technology Institute published Legionellosis Guideline 159, Practices to Reduce the Risk of Legionellosis from Evaporative Heat Rejection Equipment. This replaces their previous guideline, WTB 148. Also, ASHRAE recently published their guideline 12-2020, Managing the Risk of Legionellosis Associated with Building Water Systems. This is an update to the 20-year-old Guideline 12, published back in 2000. As a member of the ASHRAE committee that maintains ASHRAE Standard 188, I want to highlight this document and the methodology it presents for managing the risk of Legionella. The standard is not prescriptive, but rather presents a methodology and requires the development of a water management program. New York City and New York State incorporated parts of the standard into their regulations after a Legionnaire's disease outbreak in 2015, where over 130 people got sick and about 16 people died. As the standard is written in code language, we anticipate code authorities and other regulatory agencies will include this standard in their codes and regulations. This is a voluntary standard, but makes for a great way to control Legionella. I want to highlight the elements of a water management program. The standard requires the team approach. So you want people familiar with your facility and their water systems. You want to survey your facility, describe the water systems, and develop flow diagrams. And identify those water systems that present a risk of Legionella exposure. Once you have done that, you want to determine your control locations, develop control measures at those locations, and establish control limits for those control measures, and establish corrective action should the program run outside the limits you have established. The program must confirm two things. The first, the program must be verified that it is being implemented as developed through a verification procedure. The team must confirm that all actions specified within the program are being performed. The second part of confirmation is that the program must confirm that Legionella is being controlled, and this is done through validation. Typically, this is accomplished by testing for Legionella bacteria. The goal here is to validate that the water management plan is effective in controlling Legionella. As with all programs or plans, the standard requires documenting all procedures and actions. As well, the standard requires maintaining records of all actions and responses. As I presented earlier, in summary, there are two key concepts to help control Legionella. Keep the system clean with the goal of no biofilm, and keep treated water flowing with no dead legs or stagnant areas. The new guidelines incorporate these concepts in their guidance, but ASHRAE Standard 188 can be the methodology for developing a water management program to help control Legionella. ChemTreat can help you customize your water treatment program to control Legionella, as well as help you develop a facility water management plan. Thank you for following along. If you have any questions about the information provided or would like to discuss something further, please contact me through our chemtreat.com website. Thank you again.